Hello. So the question provides you some information and then asks you, um, first of all, it tells you that you have a mass hanging from a spring, and that mass is uh, zero point 0.3 kilograms, okay? And it tells you that it stretches the spring zero point 0.5 meters. And it's asking you if we place a different mass that's zero point 0.6 kilograms on the same spring, what is the length that it will be stretched? So the really quick answer, short answer, is that it will stretch the spring twice as long as the other mass because zero point 0.6 kilograms is twice the mass of the first mass, twice the size of the first mass, which means it will stretch the string twice as much. So 2 times or twice the original length, length that it stretches will be 2x, and that would equal 1 meter. That'll be the length of the spring. Now, why does that happen? Why does that work? Because since this mass is not moving, we'll draw a quick free body diagram. We have two forces acting on it. We have gravitational force, and we have the spring force, Fs. And they must be both equal because the mass is not moving back and forth, not moving at all. So they are balanced. F of Fg, force of gravity, equals mass times acceleration due to gravity, g. And we said that that must be equal to also the force of the spring. So if we set the force of the spring equal to m times g, we also have an equation for the force of spring, which is here, kx, the spring constant times the distance, or the length of the spring. So if we set those equal to each other, so to F of g equals Fs, which is mg equals kx, and if we look for x, we get x equals mg over the spring constant. So if m, or m1, is our original mass, and we want to know x2, how long will it be with the other mass? Well, the other mass is twice the value of the first mass, 2m. Same value for acceleration and the same spring constant because it's the same spring. These are all the same, so really it's just 2 times whatever it was before. It was originally 0.5 meters, now the length of the spring is 1 meter, twice as long.